Hi, welcome to my video on simplifying trig expressions number 2. And again, just more examples, and the more examples we can do, hopefully the better you understand. Simplify each. Number 1, sine theta divided by cosecant theta plus cos theta divided by secant theta. So we have fractions, but can we simplify each of these fractions first? Let's see, cosecant. So we have sine theta. Cosecant is 1 over sine theta. Cos theta. And secant is 1 over cos theta. So what I did, I changed cosecant and secant to sine and cos. Now, if I simplify this fraction here, so this is sine theta divided by 1 over sine, so we multiply by the reciprocal, which is sine theta over 1. And this one is, again, that's cos theta, and we're dividing by a fraction, so we multiply by the reciprocal of 1 over cos, which is cos theta over 1, and that gives us sine squared. And here we have cos squared. Notice I simplified each fraction first, and then I multiply. Remember, we do PEMDAS, P-E-M-D-A-S, or BIDMAS. We have to, there's no brackets to do, there's no exponents to do, so we have to multiply and divide from left to right. So we multiply, now we add. And what is sine squared minus cos squared? The answer is 1. And we have another one, tan theta cot theta plus cot squared theta. So we have an option. There are a couple of ways to do it. I could simplify. Let's see, I got cot and I got cot. So one way, I think, I have tan theta. Cot is 1 over tan plus cot squared. So tan times 1 over tan cancels, the tans cancel, so you get 1 plus cot squared. And notice that 1 plus cot squared is, oops, that's cot squared. 1 plus cot squared is cosecant squared. And cosecant squared, if you wish, you can make it 1 over sine squared, either or. So there's the order. So you can have cosecant squared or 1 over sine squared. Now that's one way to do it. Another way would be, the fundamental way would be to change tan and cot to sine and cos. So let's take it right here. Tan is sine theta over cos theta. Cot is cos theta over sine theta, plus cot squared is cos squared over sine squared. So I have them all changed. So now I have to obey PEMDAS, and that I have to do, there's no brackets to do, there's no exponents to do, so I got to do multiplication, division from left to right. So I can multiply first. So because I'm multiplying fractions, the denominators, the signs cancel out, the cos's cancel out, so I get 1 plus cos squared over sine squared. So I have a fraction, so I have to make, I want to add these. So common denominator is sine squared, so 1 is sine squared over sine squared. So cos squared theta over sine. So I'm going to add these two, so I need to change 1 to a fraction since the denominator is sine squared. So 1 is sine squared divided by sine squared. Now I have the two of them with the same denominator of sine squared. So I add these, but I can't add them because they're not like terms. I guess I can add them after, but I can't combine them to make like sine squared, cos squared. They're not like terms. Okay, and now we have sine squared plus cos squared is 1 over sine squared. And 1 over sine squared, same as here, could become, you could say, or you could say cosecant squared. Again, two different ways to handle it. So if you did it this way and did it by the fundamental, one of the identities that we proved earlier on, or you can change everything to sine and cos and work it out. Okay, let's do some more. Again, these are longer, and I meant to have them longer, so I want to do some different problems and simplifying. Now we have cos of 90 minus theta times sine, and cosecant theta times sine theta with a subtraction divided by cos theta plus 1. So let's simplify this first. So the cos of 90 minus theta is the cofunction. So that's, we changed cos to a sine of theta. So that's one of the first steps. And I can also change cosecant to 1 over sine. Okay, so I get that done. All over sine theta plus 1. So again, change cos of 90 minus theta to sine theta, and I change cosecant to 1 over sine. Now I have to multiplication here, so I have to multiply these. So I get sine times sine is sine squared theta minus the sines. This is a multiplication, so they cancel, and I get 1, and this is sine theta plus 1. And notice here I have the difference of two squares. So this is this is sine squared plus, or sorry, sine squared minus 1. So that's factorable. So that's sine theta plus 1 times sine theta minus 1, because they're the difference of two squares. And that's divided by sine theta plus 1. And they're the same, because this is multiplication and because this is factored, they cancel out. So the answer is sine theta minus 1. And we have one more to do. We have a squares. So let's put a plus here, right there. And let's square the first one. And let's square the second one. Because in PEMDAS, P-E-M-D-A-S, or BEDMAS, whatever way you learned it, you have to do what's inside the brackets, but the brackets can't be simplified because they're sine and cos, sine and cos. So we have to do the powers. So I practice squaring this. I could write down two sets of brackets and put sine and cos inside of each and work it out by FOIL. But the fast way to square this is square the first term, square the last term, and multiply these two and double it. So it's a positive 2 sine theta cos theta. And we're going to square this one. Again, we square the first term, we get a sine squared. We square the last one, we get a cos squared theta. And we multiply these two and double it. So it's a negative 2 sine theta cos theta. Because I practice squaring a binomial by, again, just to remind you of that. So a plus b all squared, the pattern is square the first one, a squared, square the last one, which is b squared, and the product of these two is 2a and double, so it's 2ab. So that's the pattern I use in squaring here. Now, because we're adding, then we don't change. So that's, I'm just going to write this out again. Now I'm showing you this. So there's the first one. Add on the second one. So there's no changing any of these terms. And now, what happens? 2 sine theta is here twice. So there it is as a plus, and there it is as a minus. They cancel out. So I got a sine squared, so that gives me 2 sine squared theta. This is cos squared, so there's 2 of them. And you'll notice that 2 is common, so we take the 2 out by factoring. So we divide this first term by 2, we get sine squared theta. Divide the second term by 2, we get a cos squared theta. And sine squared plus cos squared, that's another name for 1, that's the fundamental identity. 2 times 1 is 2. So, as you can see, we did the squaring by obeying this pattern, and we added up the like terms and factored, coming out to this final answer of 2. And again, there's some more examples of simplifying trig expressions. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content of my YouTube channel, Math Fully Explained, just one word. Thank you for viewing my video. Hope the video has helped you. Bye-bye.